All right, this problem right here is known as the amusement park problem. You'll see what they're kind of giving us here is the rate. Okay, very important to understand that this is a rate. I know it's not called E prime, but you do need to understand that this is the rate that people are entering the park, and this is the rate that people are leaving the park. So it's nice that they've kind of labeled those logical titles for you, E and T. This is a archetypical problem, right, that you will have throughout our studies this month. So I've seen problems where it talks about like the amount of sand being washed away at a beach, like you have this much sand coming on, tide goes out, this much sand goes away. We've seen the garbage problem, right, earlier this year where we talk about the amount of garbage that's coming to the landfill, the amount that's leaving. I've seen the amount of people entering auditorium for a concert, the number of people that are leaving the auditorium. So there's tons of different ways, or I guess different contexts where I see this brought up. So it's very important that you understand this kind of setup and how to do things similar to A through D. It says E of T and L of T are measured in people per hour. Time is measured in hours after midnight. That's important to note, right? These functions are valid from 9 to 23. So this is basically 9 a.m. to what, 11 p.m. The hours during which the park is open. At time 9, there are no people in the park. That makes sense because it's not open yet. How many people have entered the park by 5 p.m.? Round your answer to the nearest whole number. So part A is pretty cool. I think I can do part A just with a simple integral, right? Because they're asking me to accumulate how many people, and since this is the rate that people are entering, I'm just going to integrate that. The way that you get full credit for this, right, you don't have to rewrite the function. Please do not call it E of T. That's its name. And then we are talking by 5 p.m. They even tell you that that equals 17. So this is from the time it opened, T equals 9 until 17. Okay, and then you do have to very carefully, right, type this into your calculator in order to get the answer. Let's see, 15,600 divided by, make sure you put the entire denominator in parentheses, minus 24t plus 160. Okay, and then the way that I would do this, right, in the home screen is to do math 9, and I would do 9 to 17, and then I would use that y1 notation here, because there's no sense to retype that. Oh my gosh, I have 6,004 people that have entered the park. Think of all the money they're making, right? So I've got 6,004. This is people, and it's rounded to the nearest whole number. And I'm recording. That's okay. So we're going to go ahead and just leave that as 6,004. And then part B we're ready to go on to. The price of admission to the park is $15 until 5 p.m. After 5, the price of admission to the park is $11. How many dollars are collected from admissions to the park on the given day? There's a couple ways to do this one, right? So you could take this many people that have come into the park by 5 p.m. and multiply that by the $15, right? Well, don't put that in part A, I guess in part B. So you do 6,004 times $15, right? Plus, then you have $11 times the number of people that have come in after 5 o'clock, something like this, right? And you can go ahead and get your answer that way. I think the key shows that method as being maybe $104,041. Versus, I guess there's the second method that they show here. Like if you typed in all of this, right, you wouldn't be rounding off the whole number of people that entered and then multiplying that by 15. If you type this whole thing in, you would actually get a little bit more money, $104,048. So I'm not sure which way you would want to do it, but both of these answers are acceptable, this and this. And notice part B is worth 1 measly point. That is so sad, right? I hate that because I feel like you're doing a lot of good math here and they're not really giving you a ton of credit for it. Part C says let H of T equal the difference between the rates that the people are leaving, right, from 9 to T. So we do have a variable, right, in the upper limit. So that really kind of begs the question, oh my God, am I going to use the second fundamental theorem? Highly likely. Okay, it says the value of H of 17 to the nearest whole number is this. Find the value of H prime and explain the meaning of this and this in the context of the amusement park. So H of 17 is 3,725. So I believe that's how many people are in the park right, at t equals 17, which is 5 p.m., right, because I'm just plugging it into h. I've integrated these rates, and that's how I know that I'm accumulating the number of people. Number of people in the park at 5 p.m. Okay. Another way that you guys can think of this, maybe to help you out down here, is if you split this up and do 9 to t of e of x dx minus 9 to t of L of x dx. I think maybe this version of that function helps you understand why 3,725 is the number of people there. But sometimes when they group that integrand all together, we kind of fumble through it a little bit. Okay. The other thing it asks us to do is h prime of 17. And to find the value of that. So of course that means that we're going to have to differentiate the purple function, right? Well, apparently, via the second fundamental theorem, right, that's e of t minus L of t, right? And so this is the rate of change of people in the park. Well, actually, it's probably proper maybe to write e of 17 minus L of 17. So this is the difference in the rate of change between the people coming and going. And then we have to get these values right from the calculator. So if you type those in and subtract them, I think you get this number. Just to kind of skip over that part and make this video less long. So this number is the rate at 5 p.m. The rate that people are in the park. Don't say entering the park. This is just saying that the rate is decreasing, right? Because it happens to be a negative number. So there's people leaving, right? That's kind of winning the battle at 5 p.m. More people are leaving than are coming. That's what the negative implies. And so that's what we would say. It's very important that in your description you have the phrase, the rate that people are in the park is decreasing, right? All right, and then part D is a little bit kind of like last one. It says, at what time t in here does the model predict that the number of people in the park is a maximum? So you're finding the absolute maximum, right, of this function. Because this is how many people are in the park, right? We agreed that in part C when we said this. So we're basically asking to maximize part D. So I'm going to find h prime of t and figure out where that equals 0. So where does e of x minus L of x, oh dear, stop messing it up. Okay, get the right variables in there. Where does that equal 0, right? Because that's where h prime is going to indicate that h could have a max or a min. So I got to find the intersection of these two functions, right? I don't know, I guess I could take the time to do that here because that might involve some crazy windows. Let me get the L of x function in here. T squared minus 38t plus 370. Okay. Now I do know that I'm going to make my window, right? It's going to be between like 9 and 23, hopefully, that they are going to intersect. These values, what's a good guess? I don't even have any idea. Let's go up to 100 and see what we see. What is that? Okay, that is no good. So let's do smaller. Let's try, let's try 25. Okay, that was no good. Oh, so it was really high up there, right? So maybe I should try one, what was my first one? 300? Okay, that's better. Let me try to go up a little bit higher to see that intersection. Okay, give me a break. Okay, so we should be able to see the intersection here. I'm going to go ahead and find that value. That's where the rates are equal to one another. Okay, turns out that's 15.794. And this is probably going to be the only sign change on the interval, right? My values are 9, 15.794, and 23 when the part closes, because those are my endpoints. So let's see. These are t values. I'm trying to maximize h of t, right? So I can plug these in here. This is obviously going to give me 0. This is probably going to be when the maximum is, right? Because here, that's when the number of people leaving starts to decrease, right? So I'm going to say that this is my absolute max, because it says at what time t. So I can say absolute max at t equals 15.794, and then just say because h of 15.794 is greater than h of 23. Okay, and I guess we could physically, let me store this, x store. Okay, we could plug these in and do math 9 from 9 to a of y1 minus y2, and do d of x. And then I could do that same thing for 23. And you see that the maximum, right, is the first number, right? Oh, there's one person in there. Look at that. Okay, so 3,950 people are at a maximum there at 15.794. So you should probably fill these numbers in here so that you look more like a genius and less like you're fudging it. 0.68 and 1.013. That's hysterical. All right, that's our answer there.